Excuse me. Yeah, of course, right when the video starts, I had to cough. Anyway, this is going to be our second video of two for day 7 of Unit 3 in Algebra 2. And in it, we're going to apply what we saw in the previous video, which is sigma notation, and we're going to use it for binomial expansion. Okay, so real fast, so if we refer to like an example from the do now, right? So this right here, if I have to multiply that out actually by hand, x minus 2 all to the third power, it's not that bad, but it kind of sucks. But now imagine if I had x minus 2 all to like something crazy like the fifth power. Imagine having to FOIL that out. That would be so horrible, right? So that's where this comes in. So we can use two concepts that we've learned recently, namely sigma notation, that was in the previous video, and in the previous lesson, we learned about combinations. So putting those two things together, we can take something like x minus 2 all to the fifth power and use the shorthand that is sigma notation to easily multiply this out, quote unquote, a lot easier than if we actually FOILed it, right? So here, let's look at our first example. So uh, x plus 1 all to the third power, not so bad. Okay, but all the same, it's going to be really tedious, right? So why not use the binomial expansion theorem, right? So I'm just going to plug in the numbers where they go first. So I'm going to write my sigma out. N is going to be 3, right? K is going to always be 0 for us when using this particular theorem. N choose K, so 3 choose K. K is still unknown. And we multiply that, of course, by a to the n minus k. So a for us is going to be x to the n minus k, which is still unknown, times b. So b for us is going to be a positive 1 to the brain fart, just the k. Okay, so we're just going to expand this out. So we've got 3 choose 0 times x to the 3 minus 0 times 1 to the 0. And we're going to add that to 3 choose 1 times x to the 3 minus 1 times 1 to the first power, which we know that's just going to be 1. All of those are going to be 1, plus 3 choose 2 times x to the 3 minus 2 times 1 to the second power. And we're almost done. Plus 3 choose 3 times x to the 3 minus 3 times 1 to the third power. Okay, so 3 choose 0, we know that's 1. 3 minus 0 is 3, so x to the third power. 1 to the 0, just like we said in the earlier video, anything to the 0 power is always 1. Okay, 3 choose 1. Well, we know from the combination identities, n choose 1 is going to just be n, so that's just going to be 3. And that's going to be x squared, that's going to be 1. Okay, then we use another combination identity. So 3 minus 2 is 1. So 3 choose 2 is the same thing as 3 choose 1. In other words, it's just going to be 3 again to the x, or x to the first power, and then that's going to be 1 again. And then 3 choose 3, n choose n is simply 1. 3 minus 3, and 1 to the third power. So here we've got x cubed plus 3x squared. So x cubed plus 3x squared plus 3x. And x to the 0, anything to the 0 is simply 1. So x plus 1 all to the third power simply equals x cubed plus 3x squared plus 3x plus 1. Okay, and that probably seemed a little bit overkill. You probably might be thinking, well, I'd rather have just FOILed that. It's only to the third power. Well, now we're going to the fourth power, right? And now we're using a larger number of 5. Okay, so this is going to be a little bit uglier. Okay, so plug in your numbers. So n is 4 this time, k is 0, and I'm only going to do 2 examples for this video. There's a third one on here on this slide, but not going to mess with that one. We'll just do this third example. Or actually, I'll tell you what, this one's actually really simple compared to this other one. Let's do this one. I think this one will be a better example than the previous one. So same idea. So n is 5. We always start at 0. And we have n choose k times a, which for us is 2x this time, right? Not just x. So 2x to the n minus k. So 5 minus k. That's being multiplied by -1 being raised to the k power. Okay, so this one's going to be a little bit more difficult, right? And you're really going to want to have done this instead of foiling. Trust me. Okay, anyway, so we've got 5 choose 0. So first thing we're going to want to do is just write it all out. 2x to the 5th power, because 5 minus 0, right? -1 to the 0 plus 5 choose 1 times 2x to the 4th. And now it's just a matter of following the pattern. 5 choose 2, 2x, and I'm going to have to write really small, to the 3rd, -1 to the 2nd, plus 5 choose 3. Oh, I'm going to run out of room. 2x to the 2nd power, -1 to the 3rd power, plus, oh, maybe not. I think I've saved the space. Okay, so, I mean, you can tell this isn't requiring very much thought anymore. I'm just brainlessly following a pattern where I either subtract 1 or add 1. Well, right when I say brainless, I make a mistake. I just barely had enough room. I am the champion. I did that all on purpose. Okay, 5 choose 0. Of course, that's 1. 2x to the 5th power. So that'd be 4 times 4 is 16 times 4 is 64. X to the 5th power. And then anything to the 0 power is still just a positive 1. 5 choose 1. Well, that's just 5. 2x to the 4th power, so that would be 16x to the 4th power, times -1 to the 1st power, which would just be -1, plus 5 choose 2. And that one off the top of my head, I don't know. That's going to be 5 factorial over 2 factorial, 3 factorial. That's going to be 20 over 2 factorial, so that's going to end up being 10. You guys that are watching this, if I did that wrong, because I did it really fast in my head. If I did that wrong, please feel free to let me know. Okay, and this will just be positive 1. Okay, plus 5 choose 3. Well, that's going to be the same thing as 5 choose 2 because of the combination identity. 5 minus 3 is 2. So 5 choose 2, 5 choose 3, same thing. That's going to be 4x squared. This is going to become -1. And you notice a pattern here. We're alternating based on what power -1 is being raised to. Pretty interesting thing. That's called an alternating series. 5 choose 4. That's just going to be 5. And this is going to be +1 because it's an even power. Plus, that's just going to be 1. That's just going to be 1. And this is going to be -1. Okay, now let's simplify this all down. So 64 x to the 5th power, right? That's going to be -5, -80 x to the 4th power. 5 times -1 is -5. -5 times 16 is -80. Okay, plus we have 80 again, x to the 3rd power. And then we're going to have -40 x to the 2nd power. And then we're going to have plus 10x and -1. So you see we have the alternating thing going on here. And all of that is equal to 2x minus 1 to the fifth power. Now imagine the nightmare it would be to FOIL that out instead of doing what we did, which is following just a simple cute pattern, right? Okay, so that's going to do it for this video. Binomial expansion is tedious. It can be a long process, right? But the key is stay organized, right? Take your time, and you're going to save yourself a crap ton of frustration, uh, as opposed to if you were trying to actually multiply it out using FOIL by hand. Okay, so like always, send me an email if you need anything. Otherwise, you know where to find me. Goodbye.